Welcome back. Two portfolios can hold the exact same two stocks in the exact same weights and end up with completely different risk. The difference isn't the stocks, it's how they move together. This video is about portfolio expected return and the covariance and correlation that actually drive portfolio risk. One important point to note is that we are talking about a portfolio, so think 2 assets or more. This can mean stocks and bonds, or currencies, any combination of assets that make up a portfolio. The key point is that we are not talking about one asset, but 2 or more. By the end, you will be able to do 4 things. Calculate a portfolio's expected return as a weighted average. Calculate covariance and correlation between 2 assets. Use those to calculate portfolio variance and standard deviation. And explain in one sentence why diversification actually works. This is the mathematical foundation of modern portfolio theory. Every efficient frontier, every optimal portfolio, and the capital asset pricing model in level 2 all rest on the variance formula you're about to learn. Get comfortable with covariance here, and portfolio management stops being a black box. A lot of the material we learn here for the first time will be connected to the portfolio management topic in level 1. Here's the idea to hold on to. Your portfolio's risk is not just the risk of the assets in it, it's how those assets move together. Miss that, and you'll always underestimate or overestimate your real risk. The expected return on a portfolio is a weighted average of the expected returns of the assets in it. Multiply each asset's expected return by its weight in the portfolio and add them up. Nothing more complicated than that. For example, take a 2-stock portfolio, 60% in stock A, which has an expected return of 8%, 40% in stock B, which has an expected return of 14%. Weight times return for each stock, then add. 60% of 8 is 4.8. 40% of 14 is 5.6. Add them, and the portfolio's expected return is 10.4%. This is actually pretty similar to the concept in the video on probabilities and how we weight payouts by the likelihood of them occurring. So that was all about expected return on a portfolio. Let's now look at the other side of the coin, risk. Now, the number that actually drives risk is covariance. Covariance measures whether 2 assets' returns tend to move together, move opposite, or move independently. It's the probability-weighted average of how far each return strays from its own expected value, multiplied together. Positive covariance means the 2 returns tend to land on the same side of their averages together. Negative covariance means they tend to land on opposite sides. And covariance of a stock with itself is just its own variance. Nothing new to learn there. How does covariance connect with correlation? Both covariance and correlation measure how 2 variables move together relative to their means. Covariance shows the directional relationship between variables, positive or negative. Correlation measures both that direction and the standardized strength of the relationship on a fixed scale from -1 to +1. Now you might be asking, doesn't covariance sound like variance, the concept we saw earlier? The moment you hold more than one asset, covariance takes over, and that's what the rest of this video builds toward. For a 2-asset portfolio, variance has 3 pieces. Each stock's own variance, weighted by its weight squared. Then twice the weight of each stock multiplied together, multiplied by their covariance. That 2 only shows up because covariance of A with B and covariance of B with A are the same number. You are counting it once each, so you add them together. Memorize this formula You will use it every time you see a two-asset portfolio, but do not memorize how many covariance terms a bigger portfolio needs. Derive it. It is nothing but counting pairs, and that counting is faster to rebuild than to recall under pressure. Let's apply this. Stock A has a standard deviation of 10%. Stock B has a standard deviation of 22%. Their correlation is 0.25. Multiply correlation by both standard deviations, and the covariance is 55. Square each weight and multiply by that stock's own variance. That gives 36 plus 77.44. Now add twice the weighted covariance, 26.4. The total is 139.84. Take the square root. Portfolio standard deviation is 11.83%. Now, watch what correlation alone does to that number. If these two stocks were completely uncorrelated, standard deviation drops to 10.65%. If they moved perfectly opposite each other, it falls all the way to 2.8%. Same two stocks, same weights, only the correlation changed. This is a really important concept, not just as you prepare for the CFA Level 1 exams, but in finance. This is the entire reason diversification works. You don't reduce risk by picking safer assets. You reduce it by picking assets that don't move together. Covariance has a problem. Its units are meaningless on their own. 55 what? You can't compare a stock versus bond covariance to a stock versus stock covariance because the scale depends on how volatile each asset is. Correlation fixes that. It is covariance scaled down to a clean number between -1 and +1, so any two pairs become comparable. Divide covariance by the product of the two standard deviations. Check our numbers. 55 divided by 10 times 22 is 0.25. That's exactly where the correlation came from. One shortcut worth knowing. If you're given a run of historical returns instead of a forecast, the BA2 Plus has a two-variable statistics mode. Start with a reset. Second, then CLR work, so no old data survives into this calculation. Second, data. Enter each period's return for stock A, enter, then stock B, enter, and arrow down. Second, stat, and scroll to R. That's your sample correlation, straight off the calculator. Skip the reset, and a single leftover data point from your last question quietly changes the answer without any error message. First trap. If a question gives you both standard deviations and a correlation and asks for the covariance to plug into the variance formula, the correlation is not the answer. Multiply it back by both standard deviations first. Second trap. In a covariance matrix, the diagonal is not 0. An asset's covariance with itself is its own variance, a real, usually large number. Treat the diagonal as empty, and every portfolio variance you calculate will be too small. So far, every covariance came from a formula with the numbers already given. Sometimes you have to build it yourself, scenario by scenario. Take two more stocks. In a strong economy, growth tech returns 20% and steady util returns 14%. In an average economy, 10% and 8%. In a weak economy, -4% and 4%. Each stock's expected return is its own probability weighted average 9% for growth tech, 8.5 for steady util. For each scenario, multiply the two deviations together, then weight by that scenario's probability. Add the three results, and the covariance between growth tech and steady util is 29.5. This scales up fast. A 3-asset portfolio has 3 variances and 6 covariance terms. 20 assets have 20 variances and 380 distinct covariance pairs. The more holdings you add, the more covariance, not variance, drives the outcome. Now, pause the video and try one. Stock E has a standard deviation of 18%. Stock F has a standard deviation of 12%. Their correlation is 0.4. A portfolio holds 70% stock E, 30% stock F. Find the covariance, then the portfolio standard deviation. Covariance first, 0.4 times 18 times 12 is 86.4. Then variance, 0.49 times 324 plus 0.09 times 144 plus twice the weighted covariance. That totals 208. Standard deviation is 14.42%. So let's pull this together. Portfolio expected return is a weighted average, nothing more. Covariance measures whether two assets move together, and its sign tells you the direction. Portfolio variance combines each asset's own variance with every pairwise covariance between holdings. Correlation is covariance rescaled between -1 and +1, and it is the real engine behind diversification. The lower the correlation, the greater the risk reduction for the same expected return. Next up in quantitative methods, what happens when average risk isn't the question at all? Sometimes the only thing that matters is the chance of falling below a number you can't afford to miss. That's shortfall risk and Roy's safety first criterion. Thanks for watching, and see you in the next video.